This is a walkthrough of problem 1 on exam 1 in module 6 of the book Problem Solving Guide for Electromagnetism and Optics. Problem 1, 6 resistors are connected as shown with the values given. When a DC power supply is hooked up across the points A, B, the voltage drop across the 60 ohm resistor is 12 volts. Part A is give the current through each one of the 6 resistors. Part B, what is the rate at which thermal energy is being generated in the 100 ohm resistor? And part C, if each resistor can withstand a current of 5 amps before burning out, what is the maximum possible current that can pass through the battery? Okay, we have a good diagram. How can we start? Well, let's get the, if we're going to get the current through each one of the 6 resistors, it seems like we need the equivalent resistance of the circuit. So let's start there. What does the battery think the resistance is? We know the 20 and the 40 are in series. They're one after another. They must have the same current. So we can combine the 40 and the 20 into a 60. This 60 is in parallel with this 30. So they're connected at one end. The current coming in can go through this branch or this branch, and then it gets back together with nothing in between. That's the definition of parallel. So this 60 ohm resistance in combination is in parallel with 30, and we can calculate the equivalent resistance of those 3. So there's the equivalent resistance for 2 resistors in parallel. Substituting the numbers, getting a common denominator, we get 1 over R equivalent is 3 over 60, so R equivalent is 20 ohms. These 3 resistors combine to make a 20 ohm resistor. So we have the 20 ohms. This 20 ohms is in series with the 100, one after another. So that's a combination of 120. So these 4 resistors on the right combine for a resistance of 120 ohms. This 120 ohms, created by these 4 resistors, is in parallel with the 60 ohm resistor and the 120 ohm resistor. Current comes out of the battery. It can go through this branch, it can go through this branch, or it can go through this branch. That's a definition of parallel. So we have 3 resistors in parallel, this 120, this 60, and these 4, which combine to be 120. So we can calculate the equivalent resistance. We have 3 resistors in parallel. Substituting in the numbers, getting a common denominator, we get 4 over 120, 1 over R equivalent. So the equivalent resistance of the entire circuit is 30 ohms. The battery pumps current as if there was only one 30 ohm resistor. So, with the equivalent resistance and the battery voltage, we can now calculate the current through the battery. But what is the battery voltage? It's not given directly, but you have all the information you need. Think about it. Pause the video. Spoiler alert. The 60 ohm resistor is across the battery. One side of the 60 ohm resistor is connected directly to the battery. Nothing's in between. The other side of the 60 ohm resistor is connected directly to the battery. There's nothing in between. This 60 ohm resistor is directly across the battery. It is given that the voltage drop across the resistor is 12 volts. Therefore, the voltage of the battery must be 12 volts. So now we can calculate the equivalent resistance of the entire circuit. We have a 12 volt power supply, equivalent resistance of 30 ohms, 400 milliamps are going through the battery. So the question is, which one of these resistors has 400 milliamps? If you want to think about it, you can pause the video. Okay, the answer is none of them. The current comes out of the battery and it splits right here. Some goes this way, some goes that way. Then it splits again here, then it splits again here, and it all comes back together here and goes through this wire. This wire has 400 milliamps going through it, and then it goes through the battery. Well, there's the 400 milliamps. All of these are less than 400 milliamps because it splits. The voltage across the 120 ohm resistor is also 12 volts. It's right across the battery. There's nothing in between but wire. So we can calculate the current through the 120 ohm resistor. 12 volt battery, 120 ohms, 100 milliamps. So we found 100 of the 400 milliamps. 400 milliamps comes out at A, 100 milliamps goes through this resistor, 300 is in this top wire, 300 milliamps. Then it splits here. The current through the 60 ohm resistor, we know what the voltage drop across the 60 ohm resistor is, the voltage of the battery, 12 volts. 400 is total, 200 goes through this. So we have 100, 300, then 300 splits, 200, 100. So the 60 ohm resistance get half the current of the battery. So there must be 100 milliamps going through here because there's 300 going through here, 200 going through here, 100 goes through here. It splits again here. Splits at this junction in the upper right. Some of it goes through the 30, some of it goes through the combination of the 40 and the 20, which is 60. Now most of it's going to go here because it's got low resistance. Most of it goes through the 30. 2/3 of it goes through the 30 because it has half the resistance. So the 100 splits into 66.7 goes through the 30, and 1/3 goes through the 20 and the 40, and that's 33.3 milliamps. Okay, I think we're done with part A. We have the current through every resistor. Here's a summary. 33.3 for the 20, 66.7 for the 30. The 40 also has 33.3. It's in series with the 20. The 60 has the most, half of the battery through the current, with the current through the battery. The 100 ohm resistor has 100 milliamps, and the 120 ohm resistor has 100 milliamps as well. If you want to check that any path through the resistors from A to B should result in a voltage drop of 12 volts. So if I go back to the battery, that's 12 volts. Right here, back to the battery, that's 12 volts. I can go all the way around the outside, that should be 12 volts. To get the voltage drop across the resistor, multiply the current through it by its resistance. Now let's tackle part B. What is the rate at which thermal energy is being generated in the 100 ohm resistor? We know the current is 100 milliamps. 0.1 amps, that's the voltage drop, 10 volts. And we get the power by multiplying the voltage drop by the current. 0.1 amps times 10 volts is 1 watt, and that's the answer. But it's not obvious that an amp volt is a watt. So let's break it down. An amp is a coulomb per second, and a volt is a joule per coulomb. So the coulomb units cancel, and we get joules per second, and a joule per second is a watt. Energy per time. So now let's tackle part C. All the resistors are rated for 5 amps. The 60 ohm resistor gets the most current, so this is the one that's going to blow. If we start cranking up the voltage of the power supply, this is going to be the one that starts to burn, starts to smoke, starts to smell. The voltage needed to get 5 amps through this guy, through the 60 ohm resistor, is I times R, which is 300 volts. So 300 volts across the 60 ohm resistor, and it will burn out. Since the 60 ohm resistor is across the power supply will be at 300 volts when this one starts to smoke. The question is, what's the maximum possible current that can pass through the battery? The equivalent resistance of the circuit is still 30 ohms. So we can calculate the current through the battery because we know the voltage is 300 volts, and that's 10 amps. But we actually didn't have to calculate that. We know that the 60 ohm draws half of the current through the battery. And if there's 5 amps going through the 60 ohm, when it burns out, there must be 10 amps going through the battery. So that's problem 1. If you don't understand it completely, we recommend going through it very slowly watching it again, making sure you understand how the current branches at every junction, and making sure that you understand the voltage drop across a circuit through any path is the voltage of the power supply. The end.